video last night?
Yeah. When you went up to it, it was still focused on the board behind you, so you're like just super blurry. Just like you're just
Is
a
it
blob.
kind of cool?
What?
Is it kind of cool?
It's
No,
like
it was just
sick
blurry and you're just a blob coming out the camera. I was confused, but I'm like, I couldn't even tell what you were.
Because the scissors are already.
You can see it if you scroll down, you
This
saw it.
bag is like soggy.
We'll try again.
I'll see it.
Alright.
You can be a soggy bag.
Okay, hey, real quick.
It's just
We
like
talked about
stupid.
functions yesterday. They have domain and range. Right? Domain are the inputs, range is the outputs. Discrete are the numbers that you're plugging in. Kind of like if a function is considered discrete, it's because there's only select numbers you can plug in, not an infinite number. Select numbers like just the integers, just the whole numbers. We talked about that yesterday. Okay. Now, all right. If it's continuous, the graph can take any number. It will flow from the back to the front all the way across because it contains every real number. I think that was the example we used yesterday was real numbers. Okay? All right. Now, the new stuff we have to talk about today, like actual work that we have to get prepared for so you can see in your homework.
It smells so bad in here.
I can't help it.
I can't focus either.
All right. Hey.
Freshmen are positive.
Right?
Okay. We have to talk about proportional functions,
Maybe it's just that.
inverse functions, and we have to talk about linear functions. We're going to go through it all. Okay, we're going to do examples so you're really comfortable with what your homework's going to ask, and you can go through this. The homework's pretty straightforward. I think I assigned 10 problems today.
That is a lot. That
Ten.
is a job.
Okay, 10, and they're due by Friday. 10.
Mr. Ward,
And they're due Friday.
it is literally clear today when Lucas
very
walks
clear.
over the camera.
I was scrubbing. Let me see. Because I don't actually play the video at that part. I was just scrubbing through trying to find a good, clean spot. So,
More, it's neon.
okay. Oh, that was a good one. I should use that. Because I was just scrubbing. And if it didn't focus, I just didn't use it. 'Cause I didn't scrub.
What is that? Oh my god, Lucas.
All right.
What's the blob? What is
Okay.
that? I can't even tell.
Hey, all right, here we go. Proportional. Okay, a proportional function would be something like this. So f of x, that's the name of the function. This is the name of the function. This is the variable it's going to use. A proportional function, example of it would be something like this, where they're going to multiply a whole number out front. It can be positive or negative. It could even be, a large number, like really big integer, or really big, I guess, integer would be the main thing, but it would have to be a number that is not a fraction. If I can write it as a fraction, then that's going to be coming into the inverse function. Okay? And I'll explain the inverse, the difference in that. Okay, so what this looks like. A normal function, let's say like f of x, there's a clear difference, because what's the number in front of x?
1.
1. Well, if you were to graph f of x, like 1x, this is what it looks like.
Wow, Mr. Ward, yeah.
Now, okay, that's what a normal 1x looks like. That's this function. We'll call this g of x.
Oh,
So I can label it with g of x. Okay. Now, if we put a 3 out front, all it did was every input that I put into it made it 3 times taller. So if it was hitting 1, 1, now it's going to hit 1, 3. It's 3 times taller at that same spot for the x. If I typed in 2, it was going to go 6. Instead of hitting this, it will be 3 times taller, so it'll hit 6. Okay, and so this is what the graph is going to look like. Okay, it's 3 times taller. Same with negatives. Negatives will just flip it across. So if I go negative x, so negative x out front, what will happen here? Oh, Jesus, call this a different letter.
Whoa!
Literally stop, you're so annoying.
Yeah, that's annoying now. It's not funny.
You did it first.
So h of x going this way and this way. All right, that is h of x. This is f of x.
Is that a star?
Okay, there we go. All right. So as you can see, every time you have a proportional function, it's just moving the function from the original location. It's making it taller, or it's reversing it around to the other side. Okay, across the y-axis. Okay, that's proportional. Inverse functions are these. That's an inverse function. A number's on the, or a variable's on the bottom. Okay, you can have an inverse function. A good example of an inverse function is, a good example is like if you're doing price, like a price or the amount of money you're making per hour. Okay, because the example here is that they're going to use a fraction. They're going to have some money over how many hours you work. That's an example of an inverse relationship. It's a fraction of some sort. Typically the variable's on the bottom for an inverse relationship, but because maybe you're looking for how many hours you need to make a certain amount of money. Maybe you know that you make $11.50 an hour starting at a quick start, and you want to make $350 that week. So the idea is that what's happening here is that you need to figure out what you're taking per hour, and you're going to multiply by the number of hours, and that gives you your total. So the thing that you're looking for here is diagonal for each other. That's an inverse relationship. Because maybe you know the relationship and how hours affects. When you multiply, it's like in chemistry class, labels drop. They have really good examples of inverse relationships in your book. Most linear functions are not inverse. Because the variable is usually not on the bottom. They can have a number up front. Let's say something like this. This is what I was thinking earlier. If they do something like this, let's call this m of x. Okay. So let's say that 2/3. That is still a proportional function. Even though it has a fraction, the variable is not on the bottom. It's on the top. 2x divided by 3. Because the 2/3, that's just a multiplier. You're multiplying by a number, you're not dividing by a variable. So there's a clear difference between this side and that side of the board. What we're going to be doing today is graphing. Or looking at a graph and trying to figure out which function gave you that. So we got to know the basics about graphing again from Algebra 1. As I said, the first chapter is a lot of review over Algebra 1 and Algebra 2 stuff. We're just reviewing. So we started with functions, talking about what they are. Well, today we're talking about how do we graph them and how do they look different. So this should be, somewhat review, but it's new today. We haven't talked about it previously. Okay, so multipliers, they just changed, the tilt. If you want to move the whole graph up and down, now you have to add numbers out back. If you add numbers out back, that'll move the graph up and down. So like if I want to go to 1x plus 3, take the g function and move it up 3. Let's get rid of all this. So let's get rid of this one. All right, so here's g of x. All right, that's the original function. If I go to plus 3 on the back, it's going to shift it up 3 up on the y-axis, and it's going to go the same way. It's going to be parallel. You can make parallel lines by using the same number here, but a different number in the back. Okay, that's the basic concepts of parallelism, right? Same slope, different y-intercept.
Technically, it's not parallel.
Okay, because this is slope, this is a rate of change, which we're going to talk about here in a minute. This is a rate of, this is the y-intercept. And that's something we need to review. We're going to talk about that here in a second. Question?
I thought parallel lines didn't exist.
Shut up.
We're not going to talk about that whole story. All right. Now,
That's so true.
okay, let's go through linear functions so we can get how to graph and how if you looked at a graph, you know immediately what the formula is for. Okay? Because there's different types of linear functions. The book is going to concentrate on one type, but you should know all 4 or 5 types of linear functions. So I'm gonna try to get you to look at some of these. So let's talk about linear. Okay, linear functions, and this will lead us into the rate of change and all that. Okay, linear function. Now there's a couple different types. Number 1 is probably the most important one. That's slope-intercept. This is probably the go-to version if you're going to graph. So that's kind of the one that I would try to rearrange everything into because I like that one when I go to the graphs. It looks like this: y equals mx plus b. So what that means, you want to get the y by itself with no number in front of it. You want to get the x to the other side and a number. Now if there's no x or there's no y, then you would either have a vertical line or a horizontal line. Depends on which variable is left over, and I'll show you how to do that here in a second. But you can see it. This example I came up with is exactly in that form. Instead of having g of x, they can just put a letter on this side. They could just do this. Y equals 1x plus 3. And again, they don't need to put the 1 out front. We just assume it's a 1.
Yeah.
It's in the right form. It's got m, it's got my slope, it's got my b in the back, that's my y-intercept. Now, the m is my slope. So m, which is 1, you can make any fraction 1 over 1. You can make any fraction of 1 over 1, or any number over 1, that'll make it a fraction. What this is your rise, and this is your run from this spot, from the back number, whatever that back number is. Well, now, when I do the rise and run, I always go up and to the right. If it's negative, I go down and to the right. I just go to the right automatically. I know you can go backwards, you can go to the left. I just don't. I just go to the right, draw the graph. So if I'm drawing this one, I can start at plus 3 on the y-axis, that's my y-intercept, and then I can just do my normal numbers from there. Go up 1 over 1, up 1 over 1 to the right. And that way, it is graphing that graph that I had up here earlier. Or I go down to the right, down to the left, down to the left.
But I said down to the right.
Down to the left. If I was going the opposite of what I was just doing a little bit ago. So I just go to the right. I never worry about going left because it confuses some people.
He said down to the right.
Questions?
Spicy.
All right. Now, let's talk about the different forms because this is the go-to. This is what they always use in Algebra 1. It's the easiest one of them all. The other forms can be rearranged into this one. So if you don't like the other forms they have, I'll show you one here in a minute. We can go to the other. So the other form that the book, your textbooks use, especially in Algebra 2 and Pre-Calc and Calc, the second form they use is standard.
What?
Standard form is where they have a number in front of the x, a number in front of the y, and they have a number on the other side. So both variables are on the left side, or right, I guess, but they're together, they're not separated, they're not putting the y by itself. So an example of this would be like 2x plus 5y equals 10. That type of thing. Well, the idea is that we can rearrange that and actually solve. So if I want to take this form and I want to go graph, there are shortcuts. You probably learned them in Algebra 1, you learned them in Algebra 2, just shortcuts to figure out how to graph and what the shortcuts are. But what I do is I just change it to like this form. I get the y by itself, I move everything over to the other side, and then I can go graph it using the same rules. So what I would do, I would move the 2x over first, the other side. So if I'm going to move that 2 to the other side, it'll be 5y equals negative 2x plus 10. Because when I move it over, it becomes positive or negative. Then the last step, divide by 5. So negative 2 divided by 5, x plus 2, because I'm going to take 10 divided by 5.
You should be taking
This form is how I graph it. It's my go-to. It's the one I like. I'm going to start at positive 2. And now from there, I'm rising negative 2, so it's dropping, and I'm going to the right 5. So drop 2, run 5. 1, 2, 3, 4, 5. Do the same, drop 2, run 5. And then I can graph.
I just have 2 pages.
So you can kind of see, it shifted my graph up 2 from the 0, and it's going down to the right, because that negative slope tells me it's going down to the right. Standard is really good for story problems. You know, you went out and you bought 2 t-shirts, 5 pair of jeans, and you spent $10. Okay?
Where are you buying 2 t-shirts and 5 pairs of jeans for
Village
$10?
store. Village store.
I still don't think it would go for $10.
Anyway.
How about 2 apples and 5 bananas?
Sure.
How about 3 watermelons and
I'm not going to do this. All right, we're moving on to another form. Okay, so there's that form. Remember, I always just rearrange to get to the other ones. The other forms we have, I guess, one of the forms you guys said yesterday was Pointslope. Pointslope, and we have general. Pointslope is the one, if they give you data, if they give you random data and they want an equation for it. So like, one of the examples that I know the book does, they give you a problem like this. They say, hey, you're going to hit 2, 3, and you're going to pass through 0, 7. Figure out the equation of the line that does that. Okay, fair enough. I have the data. I can figure out slope, and I can plug it into this form because it'll get me to an equation, and that's good. I have an equation that represents that data, and it doesn't need to be in any specific form. It's this, y minus y1, m x minus x1. And what the y1 and x1 are, those are the coordinates you picked. So slope is easy, that's m, but this number and this number are one of the coordinates you picked from. Positive or negative, doesn't really matter. So I'm gonna pick probably, let's pick the 2, 3, this will be my x1 and y1. That'll be my 2 coordinates I'm gonna pick, because I just like 2 and 3, so I'll plug those in. And the only thing I'll need to find is the y, or the m I mean. So the m I'll figure out here in a second. So x minus 2 to y minus 3, because you always have to subtract whatever the numbers are. Even if it's negative, you subtract the negative. And then the slope is the one thing I'm going to have to find on my own. That's called the rate of change. Slope is this. It's taking the y numbers and subtracting. This is called an average rate of change. It's something we're going to spend a lot of time this year on. An average rate of change is when you subtract the y numbers and you subtract the x numbers, but you put the y numbers on the top. So in my case, I'm going 7 minus 3 and 0 minus 2. I'll pick one direction, I'll stick with it. 7 minus 3, 0 minus the 2. What direction you go, that's fine, but you have to put the y's on the top, x on the bottom. So if I wanted to go 3 minus 7, fine, go 2 minus 0 on the bottom. Either way, I'm still getting down to a negative number. Whatever your slope is, you can plug that in here. Now if it's a fraction, leave it a fraction, just put it out front. That's the equation. If you need to get to a different form, distribute the negative 2 and rearrange to one of the other
What
forms.
if it's a non-repeating decimal?
Leave it a fraction. I would just leave it a fraction, just deal with the fractions.
That sounds pretty tough.
Yeah. I think most part, all they do is they just ask you for the equation line that represents this. I would just leave it like right
How
there.
can we accurately represent it on a graph if we don't have an exact number?
Fractions.
You just guess.
That's not
Guess and
exact
check.
representation though.
A fraction, it'll get you close to what you need to.
Do you want to get punched?
So.
No.
All right.
I want to learn.
Hey, okay,
That's why
moving
I'm
on.
here.
Okay, point slope, the last form we need to get to.
Justin, that's school.
Okay, last
Fight Club
form.
outside of Fight Club.
This Fight Club. Didn't I just say that?
No, this is a Fight Club.
Okay, last form is general. Now general is basically almost the same as standard. When you actually see like the equation written out, I need the block marker, where's that? There it is. All right.
General?
General is basically standard, but all they did was move the C number to the other side. They want to get 0 on the one side, so everything is on the left. So general form. Now the actual like formula, you see it written down, it'll have a different letter because they're going to move the C to the other side. But it'll look like this: AX plus BY plus D
Why D?
equals
I don't
0.
like it.
Because when I move the C to the other side, it becomes negative, but it could be any number. So if it was negative, it turned positive. Whatever the number is, it's on the one side and there's 0 on the other
There's
side.
no C.
So if you want to put, a negative C, fine.
The C went away.
But if we do the quadratic formula, they use
You want to do
C,
that?
not a D, so that could really trip us up.
Yeah. But
Yeah.
they'd also have squares and other variables and not y's in there.
Ooh.
Mr.
Alright.
Ward, could you sing the quadratic formula song?
Now-
Can you?
I don't like it.
Would help me
Okay.
figure it out.
Now, rate of change. This is one of those topics I was talking about earlier. Rate of change is one of the biggest topics in calc. It's literally what Calc 1 is all about. Let me reinsert camera here.
Yeah, I know.
Oh, you didn't see it.
Calculus, the whole point of Calc 1 is to study the idea of rate of change. The change of an object and its relationship to its other variables. So, one of the things at the start of the chapters, and you're seeing in the first section, we start with slope. Mx, y equals mx supposed to be, the m is slope, that's a rate of change. It's an average rate, just generalized. Even if you had multiple data points. I know I don't think I assigned any of these, but the book has a table where it has a bunch of data, where it says these are the x's, these are the y's, and it has a bunch of numbers up here where they collected data over time. So maybe it was your weight and your height, and it was something where they were affecting each other. I don't know, weight and height don't really do that, but it was two numbers that directly impacted each other, and they were trying to figure out a rate of change between them. So an average rate is you pick any two y's, doesn't matter which two, you pick any two, and then you pick the same two x's and you subtract them using this formula. And you can plot it. That's an average. It's the distance between, because maybe the data is all over the place. Data could be all over the place. It may not be, it may not be uniform all the way across, but the average rate is it will try to get the middle ground in between.
It's like that.
It's called a best fit line. Pick the outside points, draw the line through. That's what we're going to be looking at. Hopefully that stuff makes sense, because I mean, you did an algebra 1 and algebra 2, we just have to review it. But that's a bunch of your homework today, is take data, write an equation for it, or look at graphs and give me the form that it should have been. But it's dealing with functions only, things that actually have numbers. When you plug in, there's an output into it. There's no squares, no curves, they're linear functions. Now, some of the graphs are going to show you will have curves, because they're going to just talk about like how to find domain and range. So let's talk about that one more time. This will be my last example of the day. That they might ask, so I'm going to give you an example here. They might ask for something like this, where this is a function, and the idea is that what they're going to be asking for is state the domain for that function. That is a function. What was that? The one on the right is filled. And I'll just say that it's going up 1, 2, 3, 4, 5, 6. We'll just say it's 7. That'll be a nice one. Okay?
Just say
All right, so
7.3.
So, if they want domain, I want this in what we call interval form, interval notation. So, this farthest left side is, this is 12, 11, 10, 9, 8. So that's 8. Now, do we include 8 or not?
No.
No. So what we talked about yesterday, when you write domain and range, when you write domain, use parentheses if the number's included, or no, parentheses if it's not included,
Parenthesis.
brackets if it is. So this number for my domain is a -8. I'm not including it. -8. And then I'm going to go up to the next number for my domain, which is 1, 2, 3, 4, 5. Now 5 is included. There's a solid dot there. That's the domain. That's interval form. It's easy. The range are now the y numbers. So what's the lowest y number that we hit?
0.
0. And we included. There was a dot at 0. What's the highest number in theory?
7.
7-ish?
7
I thought it was 6.3.
And we'll include it.
7.
Fine, 7.3,
7
whatever it is.
quarters.
But it has a bracket. You only use parentheses if there's an open circle or it's going towards positive or negative infinity. So if it was going towards negative infinity, like this direction, now it's going a direction, so the lowest point would actually be negative infinity, so you can't include it. That's just a direction, right? Is that an arrow? So you can have a parenthesis there. Remember, when you write an interval, the smallest number is on the left, the biggest number is on the right. And you just have to know, are you using X numbers or are you using Y numbers? Because domain is X numbers, range are the Y numbers. So now my domain would change on this problem. Because since the arrow is going this way, I would actually go towards negative infinity as well. Because the arrow keeps going, I would use all the X numbers going down.
So you'd hit negative infinity for the range before you get up to the domain. I don't know.
Okay. All right. Questions about any of the topics we've discussed today? Something that you weren't quite comfortable with, that you weren't sure of, that you haven't seen before,
Nope.
that you want to see another time?
No, it's fine.
Okay.
So didn't we do all of this last year?
Yeah, I mean, this first sections are, the review, but we're going to start getting to those later sections where you haven't seen the
Well,
stuff.
I just didn't know because you asked if we hadn't seen it before.
All right. Okay. All right, Kel, here we go. Homework. Page.
Whoa.
Let's do page 15.
Page 7.
Okay.
Ooh,
Page 7.
You know, John Brady.
Numbers 5, 6, 9, 10, 12, 14, 18, 21,
Mr. Ward.
21, 23, and 26.
You really undid yourself.
You do this last.
Okay, here we go. And it's due on Friday.
Read those numbers
Did you
out
know-
again.
August.
And Mr. Ward, you're out of Connexus now?
Thank you.
Yeah, can you read those numbers one more time?
Yeah. 5, 6, 9, 10, 12, 14, 18, 21, 23, and 26. 10 pounds, it's due Friday, you have a couple days to work on it. Now, the major thing is, our ingredient to this, is that we have book covers due by tomorrow. Okay? Yeah, I'm getting that. And good news, you already have a book cover, yay!
Yay!
Alright.
Alright.
Ow, I just got my
I took
finger.
it out. That should be all the books now.
Take these scissors back before I cut myself again.
Yeah.
Justin.
Jana, are you done with that other set of scissors?
Mom.
John Grady.
I put them back up there.
John Grady.
The black
Paul's
one,
kid.
short.
What?
Why did you guys do
At
that?
Brock's house last night, the whole kid was gouge.
Oh yeah, because I was doing so.
No, we weren't.
I saw
we
some
were
bills
staying
up
out.
front.
I'm
And-
gonna tape it on your book.
Hey, if you
No,
put like a frame from giving us any numbers with the thing
What's
eight
up?
in it, can you do that?
But he,
I really
yeah,
don't like
Mark
writing down the
has-
number
he
eight.
writes-
I love it. It's
So,
awesome.
I hate
No.
8 and I hate
But,
K.
so he, Matt writes his